recording. Let's try to do this recording, and we'll try to do video. Oh, I'm going to be on video like this today. I can do that. And let's see. Oh, no, I can't do that. I need to switch this. Okay, 1 second. There. Okay. So there's my screen. And, oh, I wish I could use the big screen. So can everyone see me kind of okay, hopefully? I can't hear anybody yet.
Yeah, we can see you.
Okay, good. All right, so wanted to talk about a little bit more about some 3D kind of stuff. Last time I had a little bit of a 3D, I was trying to do a 3D audio thing, and for some reason my 3D audio was not working, even though um, it kind of should have been. So I'm going to try to do a quick, start off with a quick demo of that. And okay, good, I'm recording. All right, so this is in that same project I was in last time, which resulted in our kind of cool, let's see, I guess we'll save that scene, our kind of cool post-processed lit scary kind of environment it turned into. Let's see. Um, don't tell me I didn't save it. Well, if I didn't save it, we'll start off, we'll create yet another one altogether, which would be cool. But for now, let's focus on 3D audio. So let's go back to our scenes. That's weird. I don't remember saying don't save, but anyway. All right. So here's a simple scene. We have this is all going on inside the universal render pipeline now still. Um, so we're set up like we were last time. The URP doesn't really matter with regards to how audio works, but it's there nonetheless. So in this scene, what I've done is I have actually 4 audio sources in here, and I got this. There's a really cool site called Sample Radar, and it's usually a music instrument. They do all kinds of reviews of music technology and so on, and they also happen to have lots of different audio loops. So if you're into production and you want to like have really cool beats of all sorts and sample loops and all kinds of stuff. There's lots of stuff royalty free that you can grab from there. I happen to grab, or I just happen to have on this machine, the Free Funky and Freaky Fill Samples set here. And it has a number of different things, and it has some drum fills, guitar, loops, keys, and synths. Unfortunately, no real drum loops. The drum fills are not quite looping. But anyway, that's besides the point. The important part is that they are just basically wave files, and they're kind of available a bunch of different tempos and so on. And I grabbed 4 different wave files, one which is a soft upright piano kind of loop, one a grand piano loop, a synth loop, and kind of a weird tweaky guitar loop that I'm using. They're in the keys of F and C, which can be sort of complementary, and they kind of go together, which is kind of cool and freaky about this. Now, what I've done is you can drag these in, drag an audio file into the scene that basically creates a audio source, which has a clip on it, and will create the default settings for that. Now, so as an example, let me, oh, what the heck, I'll grab a drum fill here. I'll give 120 beats per minute, and we'll see what that's going to sound like. Hopefully you can kind of hear that a little bit. I don't know if I got, right? All right, so I'll grab that, fill, I'll grab just any of them, I guess. And I'll just put that sort of in the scene there. And by default, it's located now at the center of the scene. And I'm going to go ahead and turn off my other ones for the time being. So we'll leave that. And I'm going to say drum fill. Notice it says play on awake, and I'm going to tell it to loop. All right, so just loop over and over and over again. So now it'll play, and it'll loop. Not all that exciting, right? So, but what I'm going to do is now I'm going to say that I want to use the 3D sound settings. So the first thing I do is set spatial blend to be 3D, and I don't want the audio, the pitch to shift according to the Doppler effect, right? This is the Doppler effect, like a train passes by and the pitch changes as it passes you because of the speed of the train relative to a standing passenger, a standing observer. We don't want that. We don't want to change that. We just want it to get louder. We're going to assume that the observer is moving in this case, not the sound. So if I press play again, now it doesn't sound much different, especially not to you. But if I go to the scene and I move the camera around, let's see, well, I'm going to take the camera and move it away. Let's try to get a little bit closer here. So it gets quiet right away in this case because the scale is very big there. So let's see. So at far away from the center, far away from that sound source, here's the camera, which happens to have the audio listener on it, right? That's the thing that's listening to the sound. Now, as it approaches here, it gets louder until it's on top of it, and it will get softer as we pass it. Right? If I see it here, if I go down here and move that main well, go to this, and we'll say don't switch. We'll go to main camera, and we'll move the camera. Do it linear here. I guess the logarithmic sounds better. Dropped off quicker. And I don't know why suddenly it's not showing me the change here again. I thought that was showing. But anyway, all right, so that's the main thing. It changes the volume. So let's do something a little bit more interesting than just change the drums there. I'm going to turn these others back on. And turn that off. Turn this on. Turn this on. Turn this on. And turn this on. And we'll turn the drums off because the drums aren't a particularly great loop. So if I go to the main camera now, you'll see I have 4 audio sources around here, each one. So there's the upright piano, the grand piano, the synth up there, and the tweaky guitar down there, and the main camera in the middle. So if I press play, somehow go to the scene here. Here I'm hearing mostly just that piano. Mostly just the other piano. Mostly the weird guitar there. And the synth up there. Okay. As I pass it, you see I'll hear even less of these. And I can position them wherever I like, right? So I can move this one, say, really far out, and then we'll go back to our main. Now the camera is close to this audio source, which is pretty far from the others. So really just hearing that one piano. So you can imagine in your game, if you have a moving camera, attached to your player, or you have an audio source attached, or an audio listener. The audio listener is attached to your player, and the player moves around in the environment, and you have these um, settings correct, so that you're playing an awake loop, and you are changing the spatial blend, right, using the 3D spatial blend as opposed to just a left-right mix there. Then you can have it so that, say you have a certain machine or an explosion or a talking monster or a grumbling, wind or something like that. You can put those exactly where you want them and have the system take care of it for you, as opposed to way back when in our original adventure game where we're doing, changing the level of the volume in order to reflect what the proximity to a sound source is. It will actually do it for you. And it'll do this in 3D as well, right? So this demonstration is more or less in 2D, but these are positioned in 3D space, so you can have it entirely work that way as well. So for the most part, we haven't really been working in 3D, but I wanted to show a little bit of that today as well. We're going to probably have a short lecture-wise, and because I know most people already have their designs together, maybe they're looking for some more feature points and so on. But maybe we'll use it for people to kind of check in, make sure, see what's going on their projects and things. But let's talk a little bit about sort of the 3D effect that you can get, or using 3D in your game. Now, if you have a game that let's see, I do have some the Brutal 2D Adventure Mega Pack here. Try to grab something simple, and we'll go to this other save now. Yeah, I don't know what I did with my scene there. Must not have saved it. So say we were to put some 2D assets in our scene like we normally would. So I'm just going to grab a background here. I'm going to grab, say, the jungle sky. We'll put that in our game. And I need to, let's see, universal pipeline, and let's see, let's make that at, why am I not seeing this guy here? Camera, sky, lit shader. Oh, I don't have a light source, right? This is the new thing. For those of you who missed the other day when we started talking about lighting, once you have universal render pipeline on, you have to make sure if you put something in the scene and it is using a lit shader, sprite lit default, this material, you will see nothing unless you have a light in your scene. So we're going to put a 2D global light in our scene, and now we will see the jungle sky, and we'll even put the jungle mountain and maybe bring that to the front. So jungle mountain here in the front of our scene, and bring a jungle tree, and we'll scale that down, and we'll bring that even more in the front. All right. So if we had just our game now, we would see not a heck of a lot going on. Maybe we adjust our camera here a bit. So our main camera, and adjust the camera to make it a size of, say, 10. And you can kind of see what's going on. We have our tree up front. We have our mountain in the background. We have, hopefully, our sky should be, that's our light, jungle sky. Why am I not seeing that at all? I probably put it somewhere where we can't see it now. Scene. It's in the back. What's going on? change the Z. Shouldn't have done that. I jumped the gun on that one. There we go. All right, so we have the sky, we have the mountain, we have the tree. Now, in all of our 2D games, you may remember that our main camera has been set to a orthographic camera, which basically means that everything is sort of splatted flat, right? There's no perspective on the viewing volume that we're seeing. So let's take a look at this. I'm going to hit this button here. It says 2D. I'm going to turn off 2D so that we will see our space here. In 3D, we can kind of rotate around a bit. Right? And what we're seeing, all right, what we're seeing, this rectangle here, this kind of rectangular volume here, is what the camera sees, right? And it sees everything just in a flat projection because it is an orthographic camera. It has no perspective. Right? Now, if I were to change that to a projection or a perspective camera, you'll see immediately that now the camera's volume is more of a pyramid, located at the camera and seeing out. We have a near clipping plane, a far clipping plane, we have a field of view, and so on, right? So it's much more like a typical camera that you would think of in the real world, right? Things that are closer to the camera seem bigger, things that are further away from the camera seem smaller, and so on and so on, right? So we have a sense of perspective because we're using a perspective camera. Now, for the most part, nothing really changed when I switched from orthographic to perspective here. A little bit, right? Because I've changed the size of the orthographic camera to 10. Now I could get them pretty close if I went back, or if I change my field of view. I'll do that here. Change my field of view to be, about 90. And my orthographic, you'll see now that's about the same, right? Because they're kind of set up very close to be what they are. Now they're definitely not the same. They just happen to look the same because I am at a distance far enough away from this plane with my perspective camera that it fills that much of the viewing volume, the frustum of the viewing volume here. Right? Once again, if I go to my scene, you'll see what it's seeing there, and it just so happens that if I look at my perspective camera, it's hitting that just about the same, right? These points where it's hitting the volume just happens to be about the same with these settings. Now, if I changed, for example, the Z depth of the camera, you'll see, of course, it changes even though we haven't changed the field of view. That's because now it's further away from the camera, so it's going to be smaller, right? That's what's going to happen to this transformation. So what am I getting at? You'll notice I never switched from 2D to 3D in terms of the game itself. There is no 2D mode versus 3D mode. It turns out that Unity is kind of always in 3D mode. I think I've mentioned this. We always had to deal with the Z depth there. It just happened to collapse everything down to that 0 for that plane that we're always working on. So if we come to our game and we decide to place something in the scene that is a 3D object, like a cube, now let's see, we have to figure out where did it put the cube. So let's put the cube at the center. Right? Ah, there it is. We start to see it here. There it is. All right, let's put it over here. And we'll bring it closer. Right? Now you'll notice it's kind of stretched and kind of squishy, kind of weird. And let's scale it up here. We'll make it 2, 2, 2. And it is a lit material, universal. Now mixing and matching universal render pipeline 3D objects and materials and 2D objects and materials. We're into something. We're in for something interesting here. Let's see if this. I think it'll still work just fine. So we've got the cube. It's now in the scene. And if I go back to my main camera and we set our camera to be orthographic, you'll notice my cube just flattened out, right? So the cube is just looks like a square because of this, again, this orthographic camera. It just flattens it out. There's no change. The front to the back of the cube there's no difference. Whereas with the perspective, it does, right? So now it looks different. So let's see. Right now it is rendering the cube as pretty boring base map and so on. Let's try to make the cube look different. Now we're getting into some of the 3D meshes and materials. This is going to be a little bit funky and fun, hopefully. All right, so by default, it uses just this kind of gray base shader here. And just like we had to sometimes create new materials or new materials that would change the way the shaders worked in 2D, we're going to do the same thing here. So we're going to create a new material, and I want it to be using Universal Render Pipeline Simple Lit. Okay. And we'll call this cube material. Right. Bad typing there. Cube material. Let's fix that. All right. And the one thing that we want to do for this cube material is also, we're going to lock that for a moment. We want to give it a texture, something different than just the normal kind of thing. So let's go maybe in our brutal animation pack, or brutal jungle pack here. Oh, we did have it. That's probably where the example wound up. Yeah. All right, found my way. Let's grab the night. Maybe we can grab a night background. Let's try it. See if we can do this. We'll grab this jungle sky. Can we do it? Make that the base map? Maybe not. Do it this way. Jungle sky. There we go. All right, so now we've set the base map for this cube material to be that jungle sky. So let's come back to our scene and say, okay, here's our cube. And instead of just using this default lit material shader, let's change this material. And we'll say select material. And there was lit. Where did we go? Cube material. Yeah, let's do that one. All right, so now we should be able to drag that cube material right on the cube. There we go. We dragged it on the cube. So if we look at the cube, I thought I had locked it. The cube is now using the cube material, which is texturing it with that sky, right? So that's how we can texture map a 3D object. And this gives us a little bit more of an indication as to its real kind of shape there, because now we can see the texture, how the map is on the side and the top. Getting into how we would change exactly how it's laid out on there on the simple cube, that is a more complex thing, which we're not going to get into so much now. UV mapping and all that sorts of stuff is definitely a more complicated matter, but let's leave that for now. The main thing I wanted to talk about was this notion of, okay, how then, say we have something in a scene now that is a 2D, we have a 2D scene or 2D assets over here, and we have this 3D object in here. How can we resolve what's going on between these things? Right? How can we use one in the game or the other? So what I'll do is I will create a player in the scene, and the player will be just an object. So let's create a 2D object, which is going to be, we'll just do a capsule in the scene. And we'll bring it to the front. Here's going to be our little player, and we will put a rigid body 2D and a capsule collider 2D, so on, right? So it's kind of a normal, typical, we'll call it the player, right? Just for the sake of it being the player. And we'll switch back to 2D here so we can just see that. So click on the player, click on this. Let's move the player kind of up, and let's give the player something to land on, right? So let's find some platform blocks here. And we should normally do this as a tile map, but we're going to try to do this just real quick. So bring this in here, drop it there, bring them to the front. All right. So here's a little platform, and we will add a component, which will be, of course, a box collider 2D. All right. So if I press play, and I've done everything in a kind of quick but dirty way, the rigid body 2D drops down. This is a capsule collider, and it, boom, hits the box collider here. It stops, right? Piece of cake. Now, what happens if I want to have it collide with this 3D object over here? Well, let's bring the 3D object down over here. And we'll grab our player. We'll move our player over here. And we'll hit play. And the problem, of course, is going to be, well, we didn't even see it there. All right, so let's get the cube to be somewhere that it can be seen. -2. There it is. Kind of looking weird because our camera is a really weird camera. Let's change our camera to be a little bit less bizarre here. We're going to move it to be -30. Right? We can move it further away, give it a narrower field of view so that it doesn't quite look as elongated here. So now we press play, and of course the capsule is going to drop and not collide with anything. Right? So we might think, well, all right, let's just make sure that that cube is at 0. Right? So the player is at 0, the cube is at 0, or maybe the cube is even at negative or 0.5. Right? So in theory now, if we look here, the cube is, I guess we put them, okay, it's right at 0, even better, right? The cube is intersecting that plane, so maybe that'll have some cool effect, right? Of course not yet, because we don't have a collider. Now here's, when you're mixing and matching, here's where it kind of becomes important to not mix and match. Because in order for physics to work, we have to have 2D and 2D. 2D objects collide with other 2D objects. So what we can do, though, is we'll just say, well, on this cube, there's going to be a box collider 2D. Right? Now, initially, it's going to say can't add it because there's conflicting with another box collider. So we're going to get rid of this box collider. Remove component. Add component box collider 2D. And you'll notice if we hit edit and we're in the scene view, the default when it builds it for us is it's going to take into account that intersection with the Z plane there, right? Right? It's 2D, it's on that 0, but it has the size of the cube. So the nice thing is now we will wind up sitting on top of that cube. Right? And let's go slightly further. Let's see. We'll go to our player, and maybe if I'm lucky, I've left hanging around some sort of... Is there a character controller? Is this character controller, which is a 3D character controller. I don't want to do that. We had circle controller. Okay, I think circle controller was a silly little script that kind of did the right thing. Let's see. Right, it's going to just get the X and Y, and it's going to move according to those directions. All right, good. Now, with gravity turned on, of course, it's going to be a little bit odd, but that's okay. So I'm going to hit that. And now we can move, and we hit that, we come over here, and we hit that. We can come to rest on top of that thing. And we come to rest on top of that thing and bump into that, and do that sort of fun thing. But the next thing I wanted to do is say, well, what if, to make this look really 3D, and there's a few things that make things look 3D. Shadow makes things look 3D, and it's perspective, obviously. And if we have a moving camera, so the point of view of the player changes, that will reinforce how 3D things look, right? Because they will shift perspective, right? So notice now, whoa, all right, that's kind of crazy. Because our capsule collider is rotating. And it's going up and down. Going to navigate in a weird way. But the main, despite what's going on weirdness-wise, all right, let's fix that. Let's make it so that our cube, what used to be our cube, no, our player is constrained so that the player will not rotate. So let's say constraints and freeze rotation here. Makes it a little bit less interesting because we'll roll now, but the important part is you'll see as we get close to the box here, I'll kind of zoom in, and maybe I'll change this relationship just a little bit here for now. You'll see the part of the box, I can move over here, I see more of that side of the box, right? Move to this over here, I'm going to see more of the other side of the box because my perspective is changing, right? So I'm still very much a 2D game here, right? All the action, all the activity, all the physics is happening on that limited z equals 0 plane, but the rendering is occurring in the 3D engine. Right, so even though we're in a 2D game, we're actually using a full-on 3D engine. And just by changing our camera from, we go back to orthographic, it's going to look an awful lot like that cube now is just no longer a cube, it's just a square. Right? So to give ourselves that fake 2D, or not so fake 2D, we just turn on the camera, and voila, it works. Right. Now the other nice thing is that this also gives us the ability to do some stuff automatically, you know, with regards to parallax scrolling, right? Which is basically having things in the background move at a different rate than things in the foreground. So let's once again go to the scene view here, and now I'm going to go into the 3D view, and I'm going to take my jungle sky, jungle sky back. And we're going to move the jungle mountain back. And we'll move the jungle tree forward. See what they look like in the game now. Kind of still see everything a bit. And now let's move. All right, so we've gotten this sort of free parallax scrolling. Right? Again, all the action is happening on that one plane. And if we had, jumping and bouncing and all that, as long as everything was consistent with regards to being in a 2D versus a 3D engine, everything would work just automatically. Right? So it's a question of getting everything to kind of be rendered in the right order. Now you'll notice even though the position is what it is, the sprite rendering that's going on, we kind of have to pay attention to two things, because we have the sprite renderer, which is determining the order in the layer. So for example, if we want this tree to be in front of the player, right now you'll see its order is 5 and the player is at 6. So we need to put the player at 4. Right. And now the player should be behind the tree. Right. So there's two pieces of information that are important. The position in XYZ space and the order in layer with regards to rendering. Okay. Sorry to jump to, someone had another question. Okay, let's get back to there. Okay. So that's the basic technique with regards to, using 3D, a combination of 3D and 2D, and kind of create that 2.5D game. Right? There are other ways to do this kind of parallax scrolling, but actually this is, as you can see, this is one of the simplest ways of doing it. You can do other things, like if everything was strictly 2D flat and you wanted to move these, you could, script the movement according to the camera's motion and then scale the motion or the location of the background according to how the camera moves. That's a technique you see used a lot in 2D engines. So you have to actually script the position of the backgrounds and foregrounds to change according to a proportion of how distant they are from one another if you just have a 2D engine. But with a 3D engine, we can kind of fake it out and make it do, or not fake it out, stop faking it out and do the right thing in this case. Right? So that's that. Now, eventually you may want to make the full-on jump to go full 3D, and everything sort of applies to all, to that, just like we had now. So instead of this being, these having 2D rigid bodies and 2D colliders, you wind up just putting 3D capsule, or just, they're not even called 3D, they're just called capsule colliders and rigid bodies and so on and so on. The one thing that you see change quite a bit is that most engines, and Unity included, will provide you with a dedicated or a sort of a custom, ready to go out of the box character controller for doing motion, right? And that is because they sort of don't, typically those character controllers don't rely 100% on just rigid body physics to work. Now you can still do it. You can, create your own character controller just like we did now, like this, having this simple controller that just uses XY horizontal vertical. But you often see games that use the built-in character controller. And the built-in character controller is how to put it? How to put it? It's sort of like it's kind of like a rigid body. It's a combination of a rigid body and a collider, and you know, all kind of rolled into one. And then you tell it to try to move. So there's an API specifically for that character controller. So I have enough time to go into it. I'm sure I'll fumble through things. Let me just give you the concept here, or let's actually, let me pull up. I have the nice thing about having another screen now. I can look for something on the other screen while we do this. I would talk about any questions on stuff so far. So if you want to go ahead, get some feature points. If you use 3D to implement parallax scrolling, that's 3 feature points. You know, you want to do that. Using a perspective camera in a seamless way, I'd say that's worth probably 2 feature points, right? So anything like that where we're kind of you're pushing the envelope, I'll try to put more definitive list, but any of these things can sort of be argued for bonus feature points, just like the lighting was, and so on and so on. So let's see here. Suddenly I'm not finding the project. My dog night project, where did it go? Wow, that one's gotten old. I'm here in just a second. All right, it's opening in the background. I think I've got the right one here. And again, you know, all the concepts still apply. That's the good thing. We like to start in 2D so that it doesn't blow people's minds with regards to all of the art pipeline stuff and the extra dimensions. So start in 2D and then extend everything to 3D, mostly in Game Dev 1. And all subsequent games, you always have the option of 2D or 3D, depending on what where your interests lie. We don't officially say, well, I think in Game Dev 1 we urge people to do 1 2D and 2 3D projects. Usually the 2D project is done in Godot and the 3D project is done in Unity and Unreal. So, good, okay. This thing is a little bit slow to load here. Not exactly the project I thought it was, but actually it's even kind of better. Assuming it still works. All right. Sample scene. All right. So what I've got here is a project that was created in an older version of Unity. And it is a 2D. We've got small element, smaller. Let's see, pull that out. So small there. So I'm going to make it bigger on the other screen, bring this back in here. There we go. You can always pop out scenes, or pop out screens, I should say, pop out windows and tabs under Unity. Bigger. It's a bit of a here, a couple of different things, and this is to whet your appetite. Use the range of a terrain, using the default checkerboard. Drag character here, action on it, to see what's going on. This set in this, and now if I press play there, it will show the character controller doing his thing. Okay. So I have the mouse changing the perspective, and the little character here. Oh, let's see, he's not grounded at the moment here, so he's slowly falling off. Let's see if we hit the. There we go. Now we're on the terrain. We can wander around again. So let's see. So we're gonna walk around, and the nice thing about the character controller, one of the nice things about the character controller, is that it's designed. Let's see, to take some of the physics problems out of your hands and do things like figure out, okay, can this object here, can this controller, can this character walk up certain slopes, and what happens when it hits a wall, and built in things. So you'll notice it runs into, it has some problems the moment it can get up not so steep slopes, but the moment it gets too steep, it kind of is no longer able to walk there, right? So really kind of quick and dirty thing here. So what I wanted to show you is kind of what it looks like using the script, because that's really kind of where it's different. It's a different type of controller. So the capsule, the, which is animated on walking the side, our little character here. Come on, let's close this one and turn off that. All right. A dragon. And the dragon will also fly around. Subject to where it is with regards to the ground. If it's close enough to the ground, you can move. And oh, well, it's got the same controller on it. So let's see. We have capsule collider, mesh render, capture, character controller. Okay. So you'll see here this character controller. It is limited in that it cannot climb slopes steeper than 70 degrees. Right? So let's see. Let's make it capable of going up 180 degrees, for example. And I guess it does make sense to show this with the walker rather than the dragon. I forgot how I had this set up. So with the right setting, wait till he touches the ground again. He's falling very slowly. All right. Get up most. I was doing better. There we go. And there are some issues with grounding here, you can tell. Right. So if we look at this capsule We have the basic controller script. So you need a combination of a character controller and you need to script what the character controller does. Right? This is where it gets a little complicated. I mean, they do a lot for you, but it gets slightly complicated in certain ways. Right? So this is a basic controller that's going to control the character controller. Right? So you are in charge of the interface, and then you have to tell the character controller how to try to move. And it will decide, can it move up a slope? Is it going to intersect with this? And so on and so on and so on. Right? So what this script is doing is during start, it is just getting the reference to the character controller that's on this object. And then in the update, it says, well, okay, is the controller grounded? Right? It automatically is taking care of that. Right? So it says if the controller is grounded, then you're allowed to move. Right? The only instance that you're allowed to move if you're not grounded is that Y you can fall down. Right? So the typical way that the controller moves is you tell the controller controller.move, and it will try to move according to how you tell it. You know, move in this direction, you know, this distance, you give it a vector. And if it can, it will move it. Right? So that's the sort of the gist of it, is that you have to calculate where you want to move, where you hope to move, and then try to move. Right? And it will tell you things like, are you grounded? Right? So if I take this off, for example, I'm no longer bothering to check whether or not the character controller is grounded. It should allow me to move all the time now. Right? So you'll see how it's moving. And we'll should have no problem climbing up these mountains now. There we go. It's a little bit funky because of the way that it collides with the mountains, the way the meshes go, and now it's slowly, very slowly dropping in space because its mass or its gravity isn't all that accurate. All right. So we are sliding around, 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 backwards, forwards, kind of left and right. And again, the main idea now is that you are not using physics, right? Typically, use of a character controller, this character controller here really isn't using normal rigid body physics anymore. It's using the colliders and so on, but you sort of have to tell it, you know, what do you want, where do you want your character or your player to go? Try to put it there using this move command, right? So that's just for future reference. After you finish your platforming game and you want to try out doing a 3D game, you're probably going to run into, like, you know, trying to use the character controller. And here's the basic idea is that once you put one on there, then you're going to say, you know, figure out what you want, where you want to move, and then try to move the character controller there, right? And then it will handle, can you move up, can you move down, is it grounded, you know, give you feedback on that sort of thing. So like for here, I think, give me some indication here, control dot, some of the things that are associated with it. Now it does have, you know, the bounds of the character controller at the center. Let's see, we had is grounded. That's one of the most useful ones. The step offset and slope limit, those are the ones that are saying, well, okay, how far does it move at, you know, per movement, and so on. So it's this kind of interesting hybrid in between fully controlled for you and not. All right, so leave that there. All right. animator that you just saw is really simple. Basically, it just has a simple walk cycle, and as long as the controller, notice controller velocity, you can ask it, what's the controller's current velocity? If it's not 0, it will run the walk cycle. Otherwise, it plays the stopping animation, which then just stops. Right? So, ability to do that. So you can query the controller for its velocity, query the controller for whether it's grounded or not, and then, depending on what's going on, try to move it in a certain direction. Right. So that's the teaser with regards to where you go next in terms of 3D in Unity. But for now, we're going to urge you to stay in 2D land, maybe go into 2.5D land, where use everything we've learned about 2D character control and first discover maybe a little bit about 3D environments, or how you can add that extra 2.5D environments where they're shown and projected as if they were in a 3D perspective, but the engine itself, the physics, the interactions, and the game mechanic itself, all the game stuff, is really kind of going on in the normal quote-unquote 2D world. Okay? So that's the food for thought, and that's the main touch of 3D for today. 3D audio, a little bit of 2.5D, and then what it kind of looks like working in 3D. Everything else in 3D, you start putting objects around, yeah, you bump into colliders. You have cubes that you collide with instead of boxes, and so on and so on. So it's not that crazy. The challenge is more, the animations are more complex because now you have 3D models and they have 3D animations that go along with them. So it's a lot of housekeeping, a lot of conversions, a lot of, so on and so on. 2D is nice in that, we're dealing more with like flipbook style animation when it comes to animating our characters versus really animating joints and skeletons and rigs and so on and so on. All right. So does anybody have any questions? No questions? All right. So that's that. So we added, using particle systems, using 2D lighting, using 3D sound, using 2D, 2.5D, lots of room for things. I posted a little video up about even using save and load if you wanted to, do something more complex. Some people had asked about, how would you, if you did an in-game editor, how would you save your levels? Things like that. We're getting into tiles and creating levels and whatnot, or auto-generating if you wanted to do a platform or environment generator or something. You could do that where you'd have it automatically generated, and then it has to be able to save and load it potentially, the next time they play the game. There's a link to a basic save and load serialization in there. You can refer to that. That's definitely worth lots of points. I would say that's a definite 5-point feature if you use serialization, and I don't mean just serialized field, but full-on serialization and formatters and so on to save data, but won't get into that too much. Okay, if there's no questions, then I'm going to stop the main feature point lecture there, and I'll stick around and wait for DMs if anyone has any specific questions about their projects or any ideas run past me. And last but not least, wanted to throw one thing out there. We are looking for, basically, if you've ever walked through the or the Sage second level, the corridor of creativity, and where the 3D printing lab is, and so on. Usually we have a flat screen up there kind of doing, showing student work, showing projects, showing, sometimes just it's animations, sometimes it's, game footage, whatever. If you are interested in potentially having some gameplay footage from any of your games, If you want to create a short video showcasing anything in particular, we are looking for things to be shown in that context. And I always love just, having potential kind of a show reel for each class. Really haven't done it as part of this class. Usually do it from my computer graphics and computer game architecture classes. But if you do have anything that you want to show off, do feel free to make a short video. Basically, you want to have like a slide introducing, title slide, and then kind of a one slide that says, you know, what's interesting about it, and then, a short 30 seconds or so demonstrating what you want to demonstrate. And we'll see. Not everything gets put up, but, I don't know who really kind of decides on the stuff out there. I haven't, because of the whole pandemic thing, obviously it hasn't been a big priority. So, all right, everybody. I'll see everyone. Again, we're just going to go ahead and make Thursday officially studio class, unless there's like some issue that everyone brings up and say, oh, or I realized at the last minute I entirely missed something they wanted to add. And we will plan on submissions and play testing and use that time this week, and next week we'll just kind of all wrap up things, and we'll see about doing sort of a little mini game fest of some, if anyone wants to share their links, so other people can play their games, get some background, maybe talk about some of the games, kind of do a brain dump post-mortem towards the end. That's always fun. All right, and last but not least, the other thing I got to mention, there's always, I should make a list. It is that time of the session, the semester, where the course evaluations are. So please be kind. Remember, it is a pandemic, and we've been sort of adapting as we go. And this is my first set of hybrid courses, so going back and forth between things and simultaneously recording and lecturing live. It can be a challenge, but am looking for constructive criticisms and ways to change the course, improve the course, things you'd like to see, things you enjoyed, and so on and so forth. So please do participate in that. It's particularly tricky when there's small classes, because everything can get easily skewed one way or another. And of course, people are usually most vocal about things they didn't like. Any kind of survey, people love to give their opinions when things are bad, but you often don't hear when the opinions are good. So I encourage you, especially if you've got good things to say, would appreciate that sort of feedback. All right. In that case, take care and take it easy, and we'll be in touch. Keep an eye on Discord for any kind of updates on things. And good luck. Let me know. Check in with me if you have any questions on your projects. Thanks.
Thank you, Professor.
Take care.